Hi everyone, I am Mustafa from DokuzEylul University, Izmir, Turkey. Today I will present you to our study experimental comparison of local scour around head section of Rubble Mound Breakwater in case of broken and unbroken waves. The coastal structures and anchorage vessels can be damaged by the effect of in order to minimize this damage, breakwaters can be built to create a calm water level in the basin. The breakwaters absorb the energy of the wave before it reaches the shore, therefore reduce the wave height in the basin. However, in the trunk section and the head section of the breakwater, scour and deposition process can be occur with the effect of waves and currents or both of them. As a result of these effects, the scour causes stability problems and damage can be occur with the breakwater body. For this reason, it is crucial to examine the scour that occurs around the breakwaters. This study aims to eliminate this deficiency in the literature and to examine the local scour that may cause stability losses in the breakwater for the broken and unbroken wave cases. The outline of my presentation: the first step, scour process in the head section of a Rubble Mound breakwater. Then I will talk about the experimental setup. Then the experiments carried out will be presented to you. And the last step, discussion and conclusion, will be talk. Scour process in the head section of a Rubble Mound breakwater. The scour process in the head section of a Rubble Mound breakwater. The scour phenomena can take place with the steady streaming. This is the case of the flow, the case of the current. And the other ones co-induced by plunging breaker in front and the other side of the head section. And the last step is the deposition induced by the steady streaming can be occur with the help of the waves that are broken on the head of the Rubble Mound breakwater. Yes, there are some pictures about our experiments. Here is our test section of the head section of the Rubble Mound breakwater, and this one is wave observer of the wave channel. The other picture for the breakwater head, and in this place there is all sand, the core sand. An experiment setup. The experiments are conducted in a wide wave channel located on the DokuzEylul University Hydraulics Laboratory. The wave channel has a length of 33 meters and a wide of 3.6 meters and the depth of 1.2 meters. In the open sea part, the offshore side of the wave channel, there is a plunger type wave generator to generate regular type waves. And on the shore side of the wave channel, there is a wave observer system to eliminate the reflection of the incident waves. In this section, there is a sand pit and the breakwater head section located to this place. The schematic view can be observed, profile, and the plan view you can see from the picture. This ramp is used to generate broken waves. With the help of this ramp, we can uh, break the waves in many types, and then broken waves affect the breakwater head. Yes, the seabed material used in the study is a medium grain size of 0.55 millimeter and 0.23 millimeters. The sand pit located on the breakwater. The sand is laying without any compaction, and after each experiment, the surface of the disturbed bed was arranged to create a horizontal surface again. The used sea-based materials in the experiments are quartz sand and have a uniform distribution with minimum geometric standard deviation. And I will talk about the measuring instruments. In our experiments, we used ultrasonic sensors. The first of these sensors is ultrasonic level system, and the according sensors, ultrasonic sound sensors. We use these sensors to measure time-dependent water levels. So we use these water levels to create wave height and wave period accordingly. Then the ultrasonic velocity profilers used in the studies to measure time-dependent Scour or deposition depth. The ultrasonic velocity profiler device is normally used for the velocity measurements, but we use the device to measure time-dependent Scour or deposition depths. The general information to how we use UVP ultrasonic velocity profiler to measure time-dependent Scour or deposition depths. You can see Guney et al. 2013. Yes, the positioning of the measuring devices in the wave channel. Here is UCC sensor, and the other one. With the help of this sensor, we can create wave height and period values, and with the help of these ultrasonic velocity profiler sensors, we can measure time-dependent Scour or deposition depths. And the third one, we use it for the particle velocity measurements. The velocity, the orbital velocity of the water particles, because of the waves surrounding around them, and the ramp in the experiments of broken waves we used for the experiments unbroken waves. The ramp is out in that. Yes. Yes, there is experiments carried out in the study. 9 different tests were conducted with 4 different wave periods, and so 4 different wave heights with 2 different median grain size of bed material. Regular waves are used, and these experiments were conducted for both broken and unbroken waves. The surface slope of the Rubble Mound breakwater is 1 per 1.5. The maximum scar depth values in millimeter unit are shown in the table. As with the help of the width of the breakwater head, we can non-dimensionalize our values and used in this table. In the broken waves case, no significant score were obtained. Resolution of ground floor and the maximum score depth is shown in the slide. In the Sumer and Freso study, the relative maximum score depth exists 0.0. There is some tables, there is some graphs with broken and unbroken wave case. This one is 0.23 millimeter bed material and 1.7 second wave period, broken and unbroken waves, time dependent scar depth graph can be shown, and with the period 2 seconds. And for coarser bed material with 0.55 millimeter and wave period 1.7 second and wave period 2.3 second. As you see, the scar is very small when the waves are broken. These pictures, the morphological forms of the bed, like ripples, can be seen. Conclusion: in this experimental study, the deficiency in the literature was eliminated by examining the local scar at the head section of the Rubble Mound breakwater for the broken wave case. In this paper, local ground movements were examined as a result of the broken and unbroken wave effects around the head section of a Rubble Mound breakwater with the experimental manner. The experiments were carried out with a specific Rubble Mound surface slope and with 2 different bed materials, sandy bed materials, and 5 different wave periods. The waves produced by the wave generator, and with the help of a ramp, the broken or unbroken waves affect the head section. Consequently, it was observed that score reduced significantly in case of the waves broken case compared to the unbroken case. In the study, we are the authors thank to Scientific and Technological Research Council of Turkey for supporting the study throughout the project. Thank you, everyone. Thanks for listening. You can send me questions to my email address. Thank you again. Bye.